let it take up just a few more, but we'll go ahead and get started here. Last week we covered, for those of you that were here last week, we covered basically full face masks. I went through the differences between the Guardian and the Spectrum full face masks. You know, we're not limited to these masks. At Ocean Technology Systems, I think that one of the secrets to our success is that if a mask has a COM port, we build comms for it. There are some older masks that we just don't service anymore. You know, the old U.S. divers mask, that they haven't been made for 30 years. We don't make comms for that. But all the current masks that are out there, we do make them for. And one mask in particular, we kind of stopped supporting simply because we had a lot of issues with the company, and I won't get into any names or anything. The primary masks we work with are Kirby Morgan M48s. The XO26, I think we're still making comms for it. It's been discontinued now for a couple of years. The Guardian, the Interspiro, you know, we're huge supporters of the Interspiro mask. Our history really is based on the Interspiro, and the success of the company was based on our partnership with Interspiro. And it's a great mask, so don't get me wrong. I'll never have anything bad to say about the Interspiro mask. You can consider it sort of competitive, but I don't, because I still teach more technician courses for Interspiro really than Interspiro does. Interspiro, Aaron at Interspiro. I don't know if Aaron's in here. Chime up if you're here, Aaron. Aaron with Interspiro does basically what I do for OTS. He does for Interspiro, but Interspiro is a broad company. They do the biggest part of their business is SCBAs. The dive industry is a small portion of that. So Aaron covers all of that. So he's a pretty busy guy. Let me see. Oh, there we go. It should be scrolling now. So, yeah, the band masks, we do make, Dave Hill asks, we do make comms for the band masks and the hats. Depends on how old. I don't know some of the older, you know, like the M48s, or not the M48s, the KMB9s, KMB10s, the 18. I think our comms will fit an 18. I haven't really played with those. At 28, it will. Hats, everything from the 17 on up, the 17K on up, to, well, they're running out of 7s at some point. If there's anybody here from Kirby Morgan, hey, John O'Neill. But we do make comms, like I say, for everything. Dan, the CO2 in the Spectrum has been tested. I don't have the results right here in front of me. If you want, we can share that with you, or give us a call. The Europeans, we do some special stuff for the Europeans as far as the Spectrum goes, and but it does. We have done a good bit of CO2 workup on it. The mouth pocket area Spectrum uses a normal second stage. Well, you do have a little bit of a dead space in there. Who asked that? It just scrolled right past. You do have a little bit of a dead space in there, so you do. I wanted to get into this, but I'll go ahead and I'll answer some of these questions as we go. Question regarding Harry from up in Canada asks the difference between the ME16R and the ME500 besides the way it's mounted. The ME500 was just a design. It's a different microphone. I'll be honest with you, I haven't played with it a whole lot. It mounts different. It uses a wire that inserts into the microphone, and then a screw you tighten the screw down on the wire. Whereas with the ME16R hot mic, you have to have the gold feet, they're brass, with gold plated brass, that now screw into the microphone itself. So it's mounted a little bit different. You could go from the ME16R to the ME500 by trimming off those gold feet. A little harder to go the other direction because you have to take the wires and solder the gold feet to go from the ME150 to the I don't have an example. I do have an example of the ME, or the hot mic, and on the inside, that's the hot mic on the inside. The ME150, that's the ME16R. The ME150 looks very similar to that, but it's a little bit it's a little thicker and a little bit different. that one, we designed that for different applications, primarily to go to the buddy phone, trying to bring costs down a little bit of the buddy phone. Actually trying to, today's day and age, it's not a matter of bringing costs down, it's a matter of trying to prevent costs from going up too much. So, well, let's go ahead and we'll get into this. Again, if you have questions, go ahead and we'll answer some of the questions, but I want to go through the basics of it. Dave asks about narrating to the camera or to the back of a Hero 8. There is a way with the 2010. And Josh and Ryan at our office, we've done that quite a bit. We have a video on our website. If you go to videos, and I tried to go to share screens, but it wasn't letting me share a screen a minute ago. If you go to our website and you go over to videos, and there's a pop down there, you can just click on videos and it'll open all the videos. If you pop down, it'll go to selected videos. And if you go to that, you'll see one called body shadowing. Or body shadowing, and it's Ryan and myself are diving off of West Palm Beach a few years ago, and what we've got there, all that audio is recorded directly to a GoPro from using SSB 2010s and our microphone assembly. So literally, what we do, and I don't have my black mask, which is set up with my rail system. I didn't bring it down here. We have the rail system that mounts on the side of the mask. The GoPro mounts out here. We literally pop the earphone out, and I'll see if this one is set up. We pop the, no, this one's not set up, but we take the earphone out, we put a piece of dual lock. If you're familiar with dual lock, it's like Velcro, but it's not the same as Velcro. It's not hook and loop. It's the little balls that snap together, and it's the same material on both sides, as opposed to Velcro being two different materials. And you take it, you put the dual lock on the back of this, and you snap it on the back of your GoPro, and it's pretty crazy how good the audio is. And you can narrate to that. So watch that video. Again, go to videos on our website, oceantechnologysystems.com. Scroll down, and you'll see body shadow or body shadowing, and all that. Again, that video is all recorded directly to the GoPro, nothing complicated. It's really a pretty simple way to do it, and it works well. Josh Roten was one of the pioneers of that. He used a video with an RX100 on the back of his GoPro on a tray, so it was kind of cool. Okay, so let's get into the program a little bit. What I want to talk about first off, and I'm going to go, this is, anybody that sat in on my lectures, you're going to hear some of this is going to sound a little familiar. The wireless communications, let's talk, first I want to talk about full face mask. Something I didn't cover, because it's integral to any communication system, is a full face mask. Now we have half masks, which you wear your regular mask and you wear a half mask, and you have two straps on your head. Regulator sets way out in front here. I used it like once and that was enough for me. It's a solution to a problem, but full face masks are really the best platform that we can put our communications in, because that full face mask gives us an oral nasal pocket to be able to articulate into a microphone mounted in said mask. There are basically, and I'm going to talk real quick about this, there's 4 reasons why we dive full face masks, and it depends on your need, so not necessarily in any particular order here of importance. One of the first reasons we dive it is for environmental protection. For those of us that were in public safety, and I was a deputy sheriff for a long time, 14 years, and military before that, but I didn't do a lot of public safety diving. I certainly wasn't well educated in it at the time that I was doing it. We did a couple of body searches and stuff like that. My very first body search was in 1979, a long time ago, and we had no clue as to what we were doing. So things have certainly changed now. But so for environmental protection, so commercial divers, people don't like commercial work and public safety, you should always consider your water as potentially hazardous to your health. You know, you're diving in water that's not what most sport divers would want to go into. If you're diving on vehicles, you're dealing with petrochemicals and hydrocarbons. If you're dealing on bodies or in you know, some of the worst environments that we dive in as public safety divers is golf course ponds, municipal park ponds. Fecal coliform is very high, and in golf course ponds, you know, that keeps the grass green and the bugs dead, it's going into that pond, and so that's certainly not, you can't imagine that's very good for your health. So with a dry suit and an attached latex hood and sealed over top of that latex hood and an attached dry gloves, you're afforded some prophylactic protection against the water that you're diving in. So now there's something else. I want to say this, and I'm going to try to say this as quickly as I can. I go out on a lot of operations and training, mostly all training, training and demonstration operations. And from a public safety diving standpoint, and as a dive, if I were the dive supervisor, I can tell you I probably kick most of the guys out of the water, because I see guys take their masks off and they let their mask drop in the water. Now, for all practical purposes, you've weaponized that water. So now they're going to take that mask, which they're wearing a dry suit and a full face mask to protect themselves against. They're going to take that wet full face mask and they're going to put it on their face and they're going to inhale. Now, what happens when you do that? Well, you aerosol that water and all the contaminants that are in it. And again, for people that have listened to my lectures before, you hear this ad nauseum. But so that that aerosol water is now the most dangerous you can possibly make it, and the most effective way to introduce it into every mucous membrane between your chin and your eyebrows, the deepest recesses of your lungs, your gastrointestinal systems, your eyes, your sinuses, your mouth, is now exposed to all that stuff that you're trying to protect yourself from. So if from an environmental protection standpoint, you need to maintain the integrity of your full face mask, keep it dry to keep that stuff out of your face and out of your body. So you're wearing that stuff for a reason, for environmental protection, as PPE, as we all, we're hearing that everywhere now. It used to be, fairly specific to our disciplines, but now it's everywhere. Everybody's talking about personal protective equipment. Okay, so enough of that. Now, so environmental protection, number one. Number two, physiological protection. If for any reason a diver goes unconscious underwater, with a 5-point strapping system that these masks have on it and sealed to your face, you're afforded, or you have a breathable environment strapped to your face. So if you go unconscious, you're not going to drop a mouthpiece. So you have that breathable environment strapped to your face. So you're afforded an opportunity of survival. And when I say afforded an opportunity of survival, there are no guarantees. But you're certainly going to be better off than you would be with a bite mouthpiece. And, you think about the newspaper reports. A diver found on the bottom without his oxygen mouthpiece in his mouth because they don't know we breathe air instead of oxygen. And, usually it comes, that, failed to revive and pronounced dead wherever on the scene or at the hospital or whatever the case may be. With a full face mask, again, at least you're afforded an opportunity of survival. Again, no guarantees. But what could happen? Any reason a diver goes unconscious, convulsive disorders. And I'm going to extend this into even more. We had a young man a while back that called me up that he was born with a cleft palate. And he'd had multiple surgeries to fix that. And in addition, he had no cartilage in his nose. And he couldn't hold a bite mouthpiece because of the reconstruction of the jaw, the features of his jaw. And a full face mask allowed him to get into diving. And he was just super excited when he got it to work out for him. So again, that's just one of many instances. People with TMJ or other dental issues that might not be able to hold a bite mouthpiece. And again, convulsive, if for any reason you go into convulsions underwater, obviously. Again, physiological. The third reason for communications, I touched on that already. Again, the oral nasal pocket with a microphone embedded in it gives you an airspace in which you can articulate into the electronics. That's what we're going to talk about next. The fourth reason is really for the diving experience. I mean, a lot of people just enjoy diving with a full face mask and communications. Also, to add on to that, the experience is a safety factor that's added for communications. When you think about it, that the ability to say, hold up, I have a problem over here, or I'm freezing, I'm cold, so somebody's going hypothermic. But just the ability to say, I need help, where without it, you don't. And you think of all the not all, but a lot of the diving accidents out there, that if that diver had the capability of saying, I have a problem, I need help, and to be able to zero in on them. I read a lot of accident reports where, last I saw them, they were right behind me. I don't know what happened, and then they're missing and gone. Happens a lot of different places. I think a Monastery Beach up in California that happened up there, a dive in particular, where that scenario came from. So and the safety factor that it adds as well. So okay, now into it. Let's talk about the full face masks and how it pertains to the communications. One of the big deals in the full face mask, when you think of the full face mask, and the ear microphone assembly, that what we do, and a lot of people look at this as some kind of magic that we do. We don't. Basically, we have a headset with a boom microphone. So you have the headset with the boom microphone. So you have your earphones, you have the microphone, and you have a push-to-talk button right here. Okay, so what do? With a full face mask, we do the exact same thing, except we make it waterproof. And in making it waterproof, and I'm not going to be able to answer a lot of questions. I'm going to scroll through and go through your questions. I'll answer them. So go back on the Facebook page, and if you should get an alert that I commented to your question a little later on. But so again, back to what we're doing. We take a headset with a boom microphone. We make it waterproof. So the microphone being on the inside here, and you can see the microphone. There you go, the little red microphone. This is weird. Oh, there you go, microphone down here. Okay, so the microphone, boom microphone. Okay, push the talk button, push the talk button. Earphones, one on each side. So now this is the ear microphone assembly. Then it plugs into your radio. Now, whoops, I just unplugged my radio, unplugged my thing here. Sorry. Okay, so what we do is we take that whip and we plug it in to the radio. Now we call this a radio. It's not really a radio. It is, as we list here, it's an acoustic telephone. Okay, so it's an ultrasonic device, and I'll talk more about that here in just a couple of minutes. But so this plugs into that. Now that's the ear microphone assembly with the SSB 2010s or the single sideband units. As you can tell, I'm starting to depopulate the couch over here. So Maya, it's good to see you there, and you're sitting on the floor as well. This is a buddy phone, and this is a transceiver. The 2010 is also a transceiver. Now, what do I mean by transceiver? And I keep doing that, keep hitting my earphone here. It transmits and it receives, transceiver. Okay, so the buddy phone is a standalone unit, and it does exactly the same thing as the other unit, just lower power and a little more convenient in a one easy package here. So with the buddy phone, you have your antenna here, which is not really an antenna, but it's a transducer if you think of it as an antenna. You also have the two screws on the front here are the water switches. On the back here, you've got the battery cap, a 9-volt battery goes in there. And then on the inside, you have the earphone that goes up against your ear. And then the cable goes down to the same microphone on the inside as the ear microphone assembly. So everything wrapped up on one neat little package attached to your mask. This puts out about 1/4 of a watt of energy, and I'll talk about energy here in a little bit. Hopefully I'll remember to cover all these topics. But it does exactly the same thing as the 2010 does. Has 2 channels, 4 channels. We have as many as 8 channels depending on the unit that you're using. So those are the 2 wireless systems we have. The SSB units, or we also have Magnecoms, which still sort of fall under that category of single sideband radios, of the external or the body attached radios, if you will. So let's talk a little bit about ultrasonic communications. Now that you've seen what the equipment is, I want to talk about signal propagation and how this stuff actually works. Now, I don't have a whiteboard here, and I wouldn't bore you with that anyway, because I'm not artistic at all. And but how we use, or how we communicate through water, underwater, is that the electronics take your voice into the microphone, into the electronics package, and it converts the human voice into an analog. Now, a lot of people claim they have a digital system. They don't. There's not a lot of people out there that do this, but when somebody says it's digital, it's digitally processed. But the signal actually going from transducer to transducer is an analog signal. So it's basically the human voice, your voice, that's translated now from what is now audible to us into ultrasound. And the frequencies, and I don't want to get too complicated, I have a tendency to over-explain stuff. The frequencies that we use in specialized equipment, we're in 8 and 11 kilohertz. That's mostly, not very many people deal with that. That's mostly submarines and stuff. Long range, low frequency, long range. And then, but for the most part, we use 25 kilohertz to 33 kilohertz, and or 33,000 hertz. And that transmits very well. There's higher frequencies. We could go higher, but we don't want to because it shadows more. It's cleaner the higher you go, but it's also less power. So the lower the frequency, the higher the power. I want you to think about something. When you hear that car, and we all know which car we're talking about, we hear that car rolling down the road, boom, 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 boom. Some guy's blaring his, or girl, blaring their music. What do you hear? you hear those bass tones, and that's the low frequency. So you don't hear the tweeter or the high frequency. So let's think about that a little bit. As we're sending signals through the water, the lower the frequency, the longer the range and the more power you can put out. Reason why. Think of it as a speaker, and the big bass speaker is a big speaker, so it's moving a lot of air. Well, a lower frequency is a larger transducer, so it has a larger surface area, can move a lot more water. The higher the frequency, think of a tweeter, not Twitter, sorry, the tweeter on your stereo speakers, and that's the little speaker that gives your high frequency, and so the higher the frequency, the smaller the transducer, so the less water it moves. So we make a compromise there. And what we found was 33 kilohertz to 25 kilohertz are the best bands for what we want to do in the ranges and the power output that we use. The Buddy phone and the Buddy phone and the SSB 2010s use common frequencies. Channel 1 through 8, channel 1 through 4, channel 1 or frequency A and B, 1 and 2. I don't want to get too complicated. You can see that on our website. We should have an explanation of that. I could write an article on that. Maybe I'll do that. I have to make a note here. But yes, they do match up. So back to frequencies, the low frequencies, high frequencies. Hopefully that makes sense. The higher the frequency, the smaller the transducer, because again, it's, compared to whoop. And again, it's low frequency has a larger, so it can move more water, so longer range. So again, it's an ultrasound. Now, ultrasound, when you think about ultrasound in water, you're thinking sonar, and that's basically it. The frequency we use are usually lower than what your depth sounders or your fish finders use. However, when you go under the boat, you can hear it tick, 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 tick through your system sometimes. And so it is something that you can hear it, but generally they don't interfere with each other. So we talked a little bit, I don't know if I did touch a little bit about thermoclines. And so let's talk about as far as signal propagation. So we send that wave out. And again, well, I don't want to bounce around too much here. Let's talk about getting that signal from one transducer to the other. So you have the SSB 2010's transducer here. It's a cylinder looking thing. And then say I've got a boat transducer that looks like this. So we've dropped this in from the boat transducer in the water. Now these transducers, this transducer is going to be excited electrically to the frequency that we're running it at, and it's going to vibrate. Now we depend on the incompressibility of water. So when you move water over here, it's going to be able to be picked up, that movement, and by the other transducer over here. So and it's a ceramic ring on the inside there that there are little micro compressions that picks it up, and that generates a little electrical signal, goes into the thing, and it translates it back down into an audible signal. So the way we have it, translated into high frequency, transmitted through this transducer, moves the water to the other transducer on the other side, and then this picks it up because this can listen. If you take your transducers and you rub them or shake keys, that's a good demonstration as to what you hear in that frequency. And then the receiver at the other side, which just happens to be another 2010 that's set up with an extension cord on the transducer, that's a surface station. It translates that signal down to the audible signal. So that's the way that works. You need to make sure you're on the same channels and so forth. So let's talk about what can interfere with the communications. Biological noise and mechanical noises. When you're underwater and you have your gear set up and let's say the squelch is open, somebody shoot me a note and remind me later on, because a lot of times I have a tendency to forget about talking about squelch. But when you have your squelch open, meaning you're picking up all the audio in the water, you're not filtering any of that out. Or squelch, think of a squelch like a gate. It opens up when you're talking and when somebody's signal's coming through, and then you're hearing all that other static, and then the squelch closes down and shuts that noise out. But then when somebody talks, boom, it opens up. When you're talking, it's open. It's transmitting different process. But anyway, so with the squelch open, you're listening to all that noise out there. Shrimp make a lot of noise, and any body of water that has shrimp in it at any given time, it'll vary. in the morning, they may be quiet. In the afternoon, evening, they could be screaming loud, vice versa. You just never know. I don't know the biology and the rhythms of shrimp out there, but you can tell the difference in the same body of water at different times of day. The shrimp can make a lot of noise, and shrimp make a snapping noise, and it can be crazy loud sometimes. I had one shrimp under me when I was working one demo, and I swear he was down there with a pie pan and a wooden spoon just banging away. Now you add that amongst thousands and thousands of shrimp in a specific area that would be within your bubble of your acoustic bubble where you'll hear them, and that all adds up to a sort of a roaring, hissing, static noise. So that can interfere with your communications in that it's noisy. The other thing is mechanical noises. If a jet ski or an outboard or a boat goes by, you can hear that Doppler shift often, where you hear the as the boat goes by. Well, that's an acoustic sound that's put in here. One of the common questions that we get are, what's the range that you can get out of the, and this gets into the power that I wanted to talk about earlier. The range of our comm gear is going to depend on the power, but it's also going to be very dependent on the my leg's going to sleep. It's going to be very dependent. On the acoustics in the area. There's a lot of other things, so I'm going to get into that because I touched on it already with the noise. The buddy phone, as I mentioned, it puts out about a quarter to a half a watt of energy. Now that doesn't sound like a lot when you think about it. It's powered by a little 9-volt battery, but the buddy phone is designed what the buddy phone is named. It's designed to talk to your buddy, so you're not going to get really long range out of it. No, it's kind of crazy. I've had as much as 1,039 yards, and I'm very specific because that's happened to be what it said on the GPS when we tested it. But we got 1,039 yards out of it. That was us tweaking it in. We like to think we know what we're doing. Sometimes the magic works, sometimes it doesn't. But that was in the Long Beach Harbor, and we had good solid bottom, good surface on it, and it was sort of like yelling down a pipe. Now, the one analogy I use for range is a conference hall and the ambient noise that's in an area at any given time. Because we're using, again, acoustics here, it's not much different than the human voice that's produced right here. Think about that conference hall. For us in the dive industry, we go to we go to DEMA every year, and at the end of DEMA, everybody's gone. You're the last ones out for some unknown reason, but the place is empty. And there's concrete floors, there's no booths, no people. You could hear somebody talking from 200 meters away in a normal voice. You'll hear them talking, and you might even be able to make out what they're saying. Now you take that same conference hall, and again, no noise, so you have no ambient noise, no interference. Now you take that same conference hall during DEMA, and while you're sitting at our booth, when you come by to visit us at our booth, wherever the next DEMA is, Orlando, I guess. Was it Orlando? I don't even remember. But you'd be hard pressed to hear somebody talking just 15 feet from you. And and I do that all the time when I'm sitting there. Some people ask me range. It's like, well, hey, hang on a second. Listen to that guy right over there, and there's somebody with you could easily just almost not reach out and touch them, but get their attention if you yelled at them. But you can't hear what they're saying, you can't understand what they're saying. So hopefully that makes sense as to what again, the ambient noise in the area is all going to make that difference. Now, New Orleans next year? No, I thought it was the year after. Well, regardless. I'm losing track. So think about that. Now, again, the same principle applies. Sometimes if you're working in an office and you're in a cubicle, you have to stick your head up over to talk to somebody. The same principle applies with through water communications. You can't pick it up just like talking on your cell phone and talk to somebody in Australia if you wanted to. It doesn't work that way. Again, we're just taking sound, putting it in the water, and it's transmitting to another unit. Line of sight is always best. It doesn't have to be line of sight, but if you think of it as line of sight, you'll get the best communications. So we talked about ambient noise and mechanicals and biologicals and stuff like that. The body shadowing and shadowing is another major factor, and I talked about that earlier, about that video, body shadowing. If you watch that video, again, go to our website, go to videos, and look at body shadowing. You'll see Ryan kind of floating in the middle of the water column there, and and it's a good demonstration. It was just an accident how it happened, but I got it on video, and I said, hey, this is a good example. I want a video clip of this, of body shadowing. And so when Ron and I were talking, my radio was behind my shoulder on my cylinder, on my tank strap. And if you're using a double tank strap, if you're using a single tank strap, you want to be careful, because as you see here with my radio, I've broken those out. And it's supposed to look like this, but I've broken those out. And that comes from cranking down on a cam band way too often, because I've been using this radio for 18 years now, 18 or 19 years. And but my radio is behind my back. Ryan's is in the same position on his. I think it's on his behind his other shoulder. But regardless, what we had is our bodies between our radios. So our lungs, our nitrogen blown wetsuits, the bubbles in our wetsuits are all an opaque object to the through water communications, and so you need to eliminate that. So when Ryan heard me say body shadowing, classic example of body shadowing, I had to repeat myself because he couldn't hear me, and then he understood what I said. And then he rotates. As soon as he heard me say body shadowing, he just naturally rotated around to where you can see his radio. I spun around. I've got a rear view mirror, which is really pretty cool for diving underwater. A rear view mirror is handy for being able to see you're not spinning. Anyway, so you see him in the rear view mirror, and our radios are now pointing to each other, line of sight, and you can hear the difference between those two communications. Between the body shadowed, not body shadowed. So keep that in mind. We get a lot of dive teams call up and say, well, we're diving in lakes and we don't have shore support. Well, our support's on shore. We don't have boats because of the particular area, be it a pond or whatever, or a small lake that they're responding to. And a lot of times you're walking for a distance before you have that drop off. And then the divers go out, they walk in, and then they get into the drop off of the lake itself. And then they're actually shadowed. So you've got this berm. Let me see where I can go here, where the surface station can't talk down around to the divers on the other side. I can't even see here. It makes sense it's backwards to me. So if you're behind or below the curve of the shoreline or the contour of the bottom, then that signal is going to go out, but it's not going to wrap around and get down to the diver below that line of sight. If that does that make sense? Hopefully that makes sense to everybody. So the trick is getting it out there. So I will recommend to a lot of dive teams, if you're diving, and everybody's environment is different. I can't tell you that this works here and works there too. You have to kind of look at it and noodle out the issues in the body of water, because every body of water is going to be particular as to how you get that signal from one transducer to the other. So keep that in mind. And what I do start to say this, with a lot of dive teams, even if it's just a milk jug and a 1 pound dive weight and a piece of 550 cord, suspend that transducer in the middle of that and try to get it out as far as you can to the near where the divers are, at least where it's got a view of the divers. So think of it that way. One of the biggest problems, and people just don't know this, but you can't take the transducer and just whip it out there and let it set on the bottom. And because if this is setting on the bottom like this and it's a mud bottom, it's just going to soak up the signal and you don't get any signal. So you need to suspend this off the bottom, get it up off the bottom, even if it's just mid-water column in 3 feet. If that signal, look at it and think about, where's that signal going? Where are my divers? If they're down below something and behind it, hide from the signal of the transducer, then you're going to have limited communications. It's just the way it goes, and you need to get that transducer out. So we've talked about the mechanical and biological noise, acoustic interference, and how that affects your underwater communications. I do need to back up at a certain point here and talk about microphone position. Don't let me forget that. Somebody shoot me a note and remind me to talk about microphone position. Other things are thermoclines, and we touched on this the other day because somebody asked me about haloclines. Halocline is a salt layer where you have freshwater, saltwater, or varying levels of salinity, and the water will separate. And we saw that a lot up in anywhere you're diving cenotes or around freshwater inlets or outlets into the ocean or the Gulf or wherever you happen to be. Cenotes, you see that a lot wherever cenotes interact with seawater. Also, we saw it, and if you ever watch Bering Sea Gold on Discovery Channel, we found it up there. I wasn't diving up there. I was just working surface support. Would have liked to have gotten in, but I just wasn't equipped at the time. But Bering Sea Gold use our equipment up in Nome, Alaska. Now, what happens there is they get the water becomes, I believe, it's hyper, in certain areas hypersaline because the fresh water is now precipitates the salt because there's minimal salt in the frozen water, and so you end up with a fairly heavy water there. And then there's also thermoclines and other things. Now, thermoclines, let's talk real quick about them. Thermoclines are both a reflective and a refractive surface. So when you think about this as a reflection, how do things reflect? And when you're talking about water, when you're off at an oblique angle, you'll get a reflection, more of a reflection than straight over above. So if your divers are offset from your surface support and your transducer is above the thermocline, the divers go below the thermocline, and again they're off at an angle. I'm trying to get in the camera here. There we go. So if they're underneath the thermocline and they're off at a farther angle, you get more of a reflection. And then also you get, and you can have, depending on the angle, you can have as much as 90% of the signal. Think about that. Going from 10 watts to 1 watt, or going from a 1 watt to a tenth of a watt. And that's a considerable loss of signal. Now, the other thing that it'll do is as that signal hits that thermocline, that which does go through is going to refract. Just like light on water. If you're looking down on a fish, you're right over above it, you're right over above it. If you're looking at a fish off at the angle, for any of the bow fishermen out there, the fish is not where you see it. So you need to aim low, right? Because that light is coming up and refracting through the surface of the water because of the varying densities of the two medium, that being air and that being the hydrostatic environment of water. So thermoclines, now the solution for that is to drop your transducer down below, if you have enough line, is to drop your transducer down below the thermocline. You can put one extension of 100 feet on all of our transducers. Don't go much farther, don't add another 100 feet because you get line loss through the additional cable there. You can push it with 100-foot extension and it should work just fine. But you will get a line loss if you extend that too awfully far. So you can extend that down below the thermocline. Now, the other thing is to get your surface support over top of your divers. So if you have the means to be able to move over top of your divers, then again, you've eliminated or reduced that oblique angle to the thermocline, and the signal will shoot down through there more effectively. So thermoclines, so we talked about interference, biological, mechanical, acoustic noise, thermoclines. One of the common questions as far as turbidity in the water. How much does turbidity affect it? Will you be able to, in muddy water? Sure, really, it doesn't have any effect on, or has minimal, if any, effect on the communications. What will have an effect on it is like red tide. Red tide puts a gas microbubbles into the water. Kelp and also fish. If you're anywhere where, in California, we have rivers sometimes of sardines and mini mackerels, and it's beautiful to see. They'll run in rivers, and you may have an issue with that. Another place where our equipment is used quite a bit is the salmon pens. And if you're using wireless communications on two sides of the salmon pens are usually like docks, set up like docks with big nets in between, and the salmon are in between those. And because all fish, most of them have swim bladders, that's filled with gas, and the signal won't pass through there. So if you've got a big school of fish between two divers, you're going to have a hard time getting that signal through. It'll be limited that way. So that's another thing that can have an effect on the signal. The red tide, as I mentioned. A common question too is swimming pools. How come our through water doesn't work well in swimming pools? Swimming pools, it depends on the water. Some swimming pools are fine. Swimming pools, because they're made of concrete and hard stuff, they can be a reflective surface. So if you're using a high-powered unit, it can be kind of overwhelming because you got that, it's like using a megaphone in a closet. It can blare pretty loud. Minimal, buddy phones work pretty well in swimming pools. But now, if you have an issue in your filtration system where it's sucking, as the line passes, as the velocity of water passes through a hole, often it'll suck water in. If it's at a valve or a joint or something like that, it can suck air into that, and it'll microbubble that. And if you look in your swimming pool and look at the ladder, and if on the ladder you see bubbles, like it's setting in a glass of Sprite, then that could be an indicator that your water is not going to be that great for through water communications. I've literally had, and it was a Ripley's Believe It or Not event out in Hollywood, on Sunset Boulevard. They had a guy on a billboard. This was one of the weirdest things. A guy on a billboard in a tank, and it was 4 feet deep by 5 feet wide. And then the depth was 6 feet, and he was just sitting down. He was going to do a world record dive on a billboard. Okay, whatever. And reality TV being what it is. You don't want my opinion of reality TV. But the guy, wireless comms didn't work at all in that small environment there. The reason why is because it would have worked if we would have hung it right next to his head. But the reason why is they were bubbling that with bubbles so that people could tell that he's in water up there. How do you know it's water if it's clear? Well, they put bubbles in it. So that interfered with the comms. So we strung him up with hardwired comms, and he could talk to the people at the television production for that. Stupid thing. Okay, so we're running a little over here, but I'm going to try to speed up here a little bit. So air in the water. So the interferences, what am I missing? Those are primary. Turbidity. Oh, aquariums. One of the things we generally with aquariums, I think we probably have some aquarium folks on here. Chime in if we have aquariums. Yeah, Brian's there. Brian Germick is on here, so he's from North Carolina Aquariums. The aquariums can be noisy because they're usually reinforced concrete and steel, and anything that's pumping and making filters or pumps and compressors and stuff like that that's attached to the same concrete that the aquarium is to has the potential of sending that in. Yeah, Rich, I'll try to get the microphones here too. It has a potential of transmitting that signal into the water, and that can interfere with your through water communications. To give you an idea how bad that can be, I was with a friend of mine, Bill Mills. We were getting ready to go shoot down in Cuba with 60 Minutes, and we were setting up our gear, doing a shakedown before we traveled, and all of a sudden we heard this noise, and it was like, what is that? In his swimming pool. We stood up in the swimming pool. His neighbor's air conditioner came on, and it put an amazing amount of noise. Hey, Justin. It put an amazing amount of noise into his swimming pool from his neighbor's central air conditioning system that went off. So think about that. Okay, I want to talk, so those are some of the things that can interfere with the through water communications. I want to talk about, and this is probably one of the biggest problems, and this is not just with through water, but also hardwire communications. I touched on this a little bit last week. But on the inside of the mask, there's a microphone. Now, this microphone is positioned well. Now, if the spectrum is kind of hard to get away from the microphone, the Interspiro mask is one that's particularly difficult. In that people will take that microphone and they shove it down into the bottom of the mask. So the microphone has to be up off the corners of your mouth. And hopefully you can see this here. See where I've got that microphone exposed there. So it's right at the corner of my mouth. At 1/4 of an inch, you lose half the volume. So what does that mean? Well, it means if you carry your divers, one of the things that you want to think about, hey, Josh, don't let me forget. Josh Shepherdson asked about moving water. I want to talk about that as well. There's another thing about moving water that's an effect that I want to address. But that microphone, again, at 1/2 inch, if you can't hear your divers, they just sound distant. Then it might be that a good example or a good thing. First thing, check the position of the microphone. that microphone has to be up here. If it's stuffed down in the bottom, the microphone is a noise canceling microphone. The hot mic is a dual-sided microphone. So, and the ME150 is as well. So in that it's a dual-sided microphone. You have a hydrophobic membrane on one side, similar to Gore-Tex, called VersaPore. On the other side is a material, it's a mylar material. So it's impervious. Nothing penetrates through the mylar material. It doesn't breathe. The hydrophobic membrane, the VersaPore, allows it to breathe. So as you go to depth, as the air compresses, as you go to depth, we all know about Boyle's law as it compresses. So it equalizes as it goes to depth. And you go to 100 feet, and it's equalized at that 100 feet, and it sounds the same, other than the density of the air going across your vocal cords will change the properties a little bit. I won't get into that. But so that's the way the microphone works. It has to be here. Now, in that, it's a two-sided microphone, just like a drum. If you have a single, film of a drum or skin of a drum, and you smack it on both sides, nothing happens. But you boom, boom, boom on one side, it picks it up. So any sound that impacts the microphone on both sides is negated, is nulled. So so that's how the noise cancellation works. It has to go onto one side. If you're talking into the end of the microphone, it's going around it, your microphone's not going to work very well. The ME150, as I mentioned, and also the Super Mic all work basically the same way. Super Mic doesn't have quite the noise canceling properties as the ME16 does. So then. And again, another thing, it's a dynamic microphone. Energy in, energy out. If you don't speak loud enough, and use your preacher's voice is what I usually refer to it as. So you want to keep your communication brief and say what you need to say and punch it out there. I mean, again, use your preacher's voice so that you're talking to a crowd. So you'll want to speak up. If you're mumbling into it, you're going to sound mumbly on the other side too. So it's a dynamic microphone. So make sure you get that going. Hey, Mitch. So keep that in mind. Microphone position. Now I want to talk too about radios as far as troubleshooting. Now I'll just touch on that. And then I'm going to follow up here with Josh's comment. When you're troubleshooting, you'll want to always suspect batteries first. And you have to go through the process of elimination when something's not working. So suspect batteries first, microphone second. Do an air test with your radios. I left my car keys over there. But you can do, we're having we're having trouble playing this video. Anybody pipe in here? I got a technical issue here. Everybody, can somebody pipe up? My screen just went blank on me. Everybody okay? I don't know what's going on here. So I've got audio, but the video is locked up. I'm not sure what's going on. You see me still? Okay. Good in North Carolina. Well, for some reason, this guy says, sorry, we're having trouble playing this video. Well, play video. All right, if you can still see me, I can see what you're looking at. But anyway, what was I talking about? Troubleshooting, process of elimination. Do air tests on your radios. You can if your squelches, depending on your squelch, if you shake your car keys to the transfer when everything is fired up, you want to short out. If you're using a 2010, you can short out with your fingers, or you can also okay, I'm still, for some reason my video is gone. Short this out with a wrench or a screwdriver or whatever, and the light will light up, and you'll be able to do an air test that way. The radio will stay on for about 90 seconds. Buddy phone's the same way. If you short out a buddy phone, you can again lay your wrench, your backup wrench for your mask, or you can lay that across there, short that out, and you'll be able to hear any communications. Take your two radios and communicate as you would underwater, but in the surface, and you can still you can do an air test that way to make sure your gear is working. Scratch your microphone and listen. I'll take my 2010. Here it is. Take my 2010 and I'll have it plugged up, and I'll key the thing, and I'll scratch the microphone. And if you lay the 2010, the cylinder here, up against your jaw, you'll hear it going ee, 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 ee. And so you're transmitting that way. So that's the way to do a quick troubleshoot. Yeah, my video is just completely gone. I don't know what's going here, but you can still see it. All right. Now back to Josh's point. Was it Josh? I'm scrolling back here. Moving water. Um, how does moving water affect the communications? Generally, it doesn't, unless you're in some place. No, don't have screensaver up. Generally, if you're someplace like Puget Sound, we did have an effect up there that was kind of interesting. I was working with Canadian military up there, and I think what we had there were shear lines, and so with the shear lines where you have two currents come together, and one's going one direction, one's going another direction, that creates a similar effect to a thermocline. So that's one thing that I think the only thing. But the other thing is in rivers, and I found this out diving the Colorado River many years ago. Tumbling stones. That if you're anywhere near riffles or rapids, where if you notice, you'll see this when you're drifting the rivers. If you ever have a chance to dive there at Laughlin, Nevada, down below the dam there, it's a wonderful dive. It is one of the coolest dives, and it's clear water, cold, and there's a big thing called the swirl, big eddy that you can get in, and it's deep. It's like 65 feet deep, and it's really a cool dive. Jeff Morgan's not on here, I don't think, today. He was on last week, but he and I did that dive several times. It was great. But anyway, if you look behind the rocks, you'll see a big rock. You'll see the current going by, and you see these little tumbling rocks, and they're all bashing against each other. And so that will put an acoustic noise into the water, just like anything else, and that can interfere from a standpoint of having a lot of noise in the water. Again, just like the conference hall with the people standing around rabble, rabble, rabble. Yeah, Brent. My video is completely gone. I don't know if this is going to affect the recording. When I download this or when I save this to YouTube, or not YouTube, we are going to put it on YouTube. But if it's saved there, anyway, so those are. I've bounced around a lot, but hopefully I covered a lot of the subjects here with wireless comms. Does anybody have any specific questions? That I know there's a lot of them scrolled past. I just couldn't read at the time because they were blasting past me, and I didn't get a chance to. Again, ask the question in the feed here, and I'll go in and I'll do follow up where I'll go through all your posts and questions, and I'll answer them. You should get a notification that John answered or replied to your comment. And we went a little long on this. I wanted to keep it down, but I really wasn't locked into anything specifically. We're at 54 minutes right now. I haven't decided on what we'll talk about next. Comment as to what you'd like to hear, what you'd like me to address, and I will. I'll go through it and sort of by show of hands, we'll talk I'll talk about different subjects. Hardwire is easy. I could cover that in the future. If anybody's interested, I could do one. This is going to be a little more limited, a little more of a niche. As far as putting underwater audio to your video, I could cover that. That we also, just as a couple of things, go to our website and use our website. If you haven't registered, go ahead and register on our website. And we don't spam you or anything. You might get a monthly newsletter. That's about it. And we'll get that out to you. But there's a lot of resources on there is what I'm getting at. Our video section, look at that. Read the manuals. If you don't have the manual for the piece of equipment you have, that it should be available in our library there. So user manuals are a big deal. People, trust me, read the manual. You'll learn a lot. It's a good resource. And then don't hesitate to give us a call. You've got me on Facebook here. If you're not on my friends list on Facebook, you have any questions, I do a lot of business on Messenger. So I want to go ahead and cut this now. You guys, thanks a lot. Again, post your questions. I'll get back to answering them. And I look forward to it. I might be doing this every week. So we'll probably be doing another one once we figure out what we're going to talk about next week on Thursday. Same time, same channel. All right. Well, thanks a lot for showing up. I appreciate it. You all stay safe out there. Stay healthy.